In this video, we are going to take a look at composition of functions, which is the first half of our section 1.4 in our pre-calculus class. Okay, so we're going to do composition of functions. For example, you may recognize from your Algebra 2 class a notation that looks like this. F of g of x, or it may have been written f parenthesis g parenthesis x and then close both of those. Either way, you say, not sure what that was right there. Hold on here. We'd want to say f of g of x. Okay, that's what that says. Okay, as far as domain and range goes, something kind of to note here is that the range of g becomes the domain of f. Okay, so let's look at a couple examples, what we're talking about here. Okay, let's say that f of x equals x squared minus 1, and g of x equals the square root of x. Okay, and perhaps the first composition we want to figure out is f of g of x. Okay, so essentially what's going to happen is that in this case, g of x, whatever g of x is, in this case square root of x, is going to be plugged into the f function for x. So we're going to take square root of x and substitute it in over here. Okay, so what does that look like? Well, we're going to do something like, take this over here. So we're going to end up with square root of x squared minus 1. Well, when you square a square root, you get what's inside, so just x minus 1. So that's going to be the value of f of g of x. If we wanted to state the domain, okay, you've got to think about square root of x in this case. Okay, so the range of that goes from 0 to infinity, and that would take care of our domain. All right, let's take a look at a second example. Suppose we switch this around and we say g of f of x. Okay, so this time, I'm just going to make a mess of your notes. This time, f of x substitutes into g. So this time we're going the other way. So this f of x part here is going to substitute inside there for x. Okay, so what does that look like? Well, it will become f of x is going to go inside here. So the square root of x squared minus 1. The whole thing goes inside. Okay, and that's the value of your composition. Okay, so then this time, if we think about our domain, okay, so x squared minus 1. So if you remember, you're going to look at a parabola, and it's going to drop down 1. So what's that doing with our domain? Should do something like negative infinity to negative 1, union 1 to infinity. And we could support that with a graph if we wanted to. Okay, so let's take a look at a second example. Okay, this time let's do something like f of x equals 2x minus 3, and g of x equals x plus 3 over 2. All right, so first let's do a composition of f of g of x. Okay, so the g function is going to plug into f. So it's going to be like taking f of x plus 3 over 2. Okay, that's essentially what we're doing. So we'll do 2 times x plus 3 over 2 and then a minus 3. Okay, so in solving that, we can cross-reduce our 2's. Okay, and we'll get x plus 3 minus 3, which simply equals x. Okay, that will be our composition, f of g of x. Domain for this one is simply negative infinity to positive infinity. Okay, using the same two functions, let's calculate g of f of x. Okay, so what does that mean? Well, this time we want to do a g of 2x minus 3. Okay, so if we were to substitute in, we're going to have 2x minus 3 plus 3 all over 2. Okay, so we end up here with 2x over 2, which is equal to just x. So we are negative infinity to positive infinity once again. Okay, so the second thing I wanted to share here is if we do some additions and subtractions with functions. Okay, so for example, let's consider f of x this time to be 4 plus x, and g of x to be 2 minus 3x. So suppose they ask us, or we have a problem that says do f plus g. Okay, so that's great. We can just do some polynomial addition. So 4 plus x, and then we're going to add that to 2 minus 3x. And if you just go through and add like terms, we have 6 minus 2x. That's all you get. Okay. We could do one, let's say we subtract the polynomials in this case, f minus g are the functions. So we'll do 4 plus x minus 2 minus 3x. Okay, and this time make sure that you change your signs inside. So if we're going to do a 4 minus 2, it's 2. And then x minus negative 3x is going to become a plus, so that's a plus 4x. It might be helpful if I were to show it here in this middle as doing change to a plus, and then it's negative 2 plus 3x. Maybe that's a little easier for you to see. So 4 and negative 2 is in fact 2. X plus 3x makes 4x, and that's what we had for the answer. Isn't that just so cool? All right, and one more here. We could do f times g. So that becomes 4 plus x times 2 minus 3x, the two quantities. So it turns into a problem where we're going to do FOIL. So 4 times 2 is 8. 4 times negative 3x is a negative 12x. In the middle there is a 2x, and then an x and a negative 3x is a negative 3x squared. And again, combining like terms, we're going to have, I'm going to put it in descending order. So negative 3x squared, the middle condenses to minus 10x, and then a plus 8. Okay, and that will end up our product of functions. Okay, so again, this has been compositions of functions, f of g of x, g of f of x, looking what we get when we combine functions, and then taking a quick look at their domains. Good luck with your studying.